Our first decoder to speak about is the protected storage decoder. We simply worked with Microsoft protected storage. And let me tell you a little bit about the protected storage itself. So the protected storage is basically really is just the registry keys. It's just the registry keys which are stored, dedicated. So there are dedicated set of the protected storage registry keys for each user account, and there is also the dedicated set of registry keys for the computer account itself for a local system. And the protected storage was first introduced in Windows NT and it was available for access till Windows Vista. And inside in the Windows Vista, it was made read only. So all of the applications they were able to read information from protected storage, but they were not able to write any information inside. So it was available for read only in Windows Vista and Windows 7, and starting from Windows 8 and right now till Windows 10, the protected storage was completely decommissioned. So there is no protected storage in Windows 8 and Windows 8.1 and Windows 10. And the reason why it was made the read only because in Windows XP the new technology to securely store the credentials was introduced, and it was the credential manager, which was better and more secure than protected storage. And the protected storage was not really enough secure for that time, so it was considered not secure. And again, just the main idea of the protected storage is to give the ability to user accounts, to users, save some information, and most of the time that's the credentials like username and password inside of the protected storage, and the access to that information will be given only to the specific user. So nobody except these users, and it's per user storage, so nobody except that user, specific user, will be able to access that information. And there is a dedicated storage for computer object for computer account for the system account itself, and no one except the system account is able to access that information. And let me show you um, the registry path. So we have that's our Windows 10 machine, and that's the registry path here. So it's current user, software, Microsoft, and here it should be the protected storage provider. Uh, but there is nothing like that here. And let me show you the official Microsoft documentation about that. And you can read here that the protected storage blah 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 was read-only unavailable, and there are some functions from Crypto API which you can use to encrypt the data for the user and put it inside of the protected storage, and then get the information from the protected storage to unencrypt the information. There is also some information here about the like technical details, but I don't think it's. If you wish, you can read that article. It's the dedicated page section for the protected storage. Uh, and there is also good help in the Cain itself. We can click that button, the help button, go to the Cain help, password decoders, and the protected storage here, and you will see that that's the registry key which should be here. Okay, you see protected storage system provider, that's the key name, but we don't have such a key here. And there are some, you see, all the applications which use that protected storage, the Microsoft Outlook, 2002, or by the way, even Internet Explorer version 4, 5, and 6, they used protected storage to store the basic authentication passwords and some other application. But most of them, even I think all of them, they are deprecated and legacy right now. They are not in use anymore. And that's why if you trying to get the uh, passwords or secrets from the protected storage, you click in the plus button, you're getting that error, which means that basically there is no protected storage inside of the Windows 10, and the Cain cannot find the protected storage. And the same error you will get in Windows 8. The protected storage is nothing here, and the same problem with the Windows 8. Sorry, the previous was Windows 8.1. This one is Windows 8. But Windows 7, because I told you that inside of the Windows 7, it's still available for read-only access. There is a, you can see we were able to read the protected storage, but we didn't find anything inside. And let me show you that that key is really here. So current user, software, Microsoft, and then protected storage. That's the protected storage. And you see here, that's the protected storage container or key for our specific user, and that's the SID security identifier of our account, and that's the read relative identifier. So that's why my um, current account, I think. Let me check. You can use who am I as user, and that's my account. Yes, 1001. So again, the protected storage basically is the old Microsoft technology to securely store credentials for each user separately and the computer account. But because it was considered not secure and it was deprecated basically in Windows 8, but it was not available for write access starting from Windows Vista.
The next decoder which we will speak about is the LSA secrets. So the LSA secrets is a very interesting storage because it contains the information, the private information for our operating system. It's basically the dedicated storage for our local computer or a local system account, and can be accessible only by the local system account by default. So when we have many interesting things stored inside of the LSA secrets, and that's the Windows 10 here. We have Windows 10 as a first example, and let me show you first what is LSA secrets um, in reality. So really, the LSA secrets is just a bunch of registry keys, and they are stored inside of the local machine security key, but we cannot see anything inside by default. But what we can do, because we are local admins and domain admins, we can change the permissions for that object, and we are by default owners of any object inside of the registry. So, and I'm the member of administrators, and what I can do is, you see the administrators here. So we are here, but for some reason by default we do not have that permission, the read permission. But what we will do, we will just assign read permissions or full control to ourselves. Click OK here, and just replace all of the permissions for all the included or child objects of that registry key. Let's click apply here. Yeah, I want to continue. That's okay. It's okay here. And right now we can click F5, and you see that we are able to go inside with no problems. And that's the path. So the HKLM security policy and secrets, and that's the local LSA secret storage. And here we have some interesting objects. And let's speak about each of them in more details. So the first object is the, you see, $machine.ac. So sounds like machine account something. And let me show you the structure here of every LSA secret. So they are the same. The structure is pretty easy. So that one, current value, that's the current value of that secret. The old value, that's the previous value of the secret. Sometimes they are empty, sometimes you should keep the previous value, but it's, again, this one is the current update time. So that's the timestamp when the when that secret was updated, the current value. And this one is old update time, and that's the value when the previous old, this one, old value key was updated. Okay, so let's speak about the machine account secret first. And it's pretty easy to give you the understanding, to show you what is the machine account secret. So let's say we have the domain join computer, workstation or server, and that's the domain controller. And during the computer startup process, boot process, we will have the following thing. We'll have on the background the computer object authentication will be performed. So that computer account is domain joined, and we will authenticate and get the response from the domain controller if we are good and legitimate computer account, which is domain joined. And after that, we will be able to authenticate using our user account. And that phase is pretty common because you can type your password or enter your PIN code for the smart card or something like that, or biometric something. But that part, that's one, we don't see that part because it's happening on the background before you will be able to authenticate using your user account. And basically speaking, the password for computer account is stored inside of our LSA machine account secret. So during the startup, the computer will read current machine account password from our LSA secrets and will perform the authentication. And the copy of that key of that password is stored on the domain controller. And if the password is not the same, then the authentication will be cancelled, will be declined. If everything is good and they are the same, then after that the authentication will be successful. So, and we also stored the previous value of the machine account password and the current value of the machine account password. And the machine account password is 120 characters long. So I don't want to go deeper inside of that topic, but for you to understand the idea of the machine account uh, LSA secrets, that's the basically the password of the computer account for domain authentication. And if you have that information, you theoretically can perform the domain join attacks. You can join the non-legitimate um, computer to the domain because you already know the computer account password for another computer, but it's a little bit more complicated. Okay, so the main idea here is that right now we know what is machine account secret. The next secret is the default password. And the Windows systems, they have the specific feature which is auto logon, and you can specify the account which will be automatically authenticated during the system startup, and the session for that account will be created. And the password for that user account will be stored inside of the default password LSI secret. And I will show you how it looks like later when you will see the content or see what is saved inside of the default password LSI secret using Cain and Abel. The next secret is the GP API system. So basically it's data protection API system key, or the key for the system account, which is the local computer account. Um, after the protected storage was deprecated, um, there were new APIs, which is data protection APIs, developed. And data protection APIs, they give you the ability to do kind of the same things which you were able to do with the um, protected storage. You're able to save or store the information like passwords or keys for user accounts. Those there are dedicated storages for the user accounts, and there is also additional storage for the computer account itself, and that storage is basically all of the information inside of that storage is encrypted using the data protection API system key. And for now we just can, that information is enough for now, but later we'll see some examples of where the system key, data protection API system key is used, and how we can and especially it's used inside of the credential manager. We'll speak about about the credential manager later. And the last LSA secret is the last here is the annual $KM. So the annual $KM secret is basically the key which is used for encryption and decryption of Windows cache credentials. And by default, that's the last 10 domain user accounts which were logged into that specific to our local machine or our computer. And that's the basic explanation of cache credentials. And we will speak about cache credentials later because we will see that Cain can show you uh, all of the cache credentials which are saved right now on our machine. But just keep in mind that to be able to encrypt or decrypt, which is more important, all of the cache credentials, you must have access to that NLKM key. Um, Inside of the LSA secrets, you may also find the passwords for local services. And if your local service configured to run under the real account, user account, instead of some built-in local service or local system accounts, then you will be able to find the password for that account saved inside of the LSI secrets. So let's do the experiment here, and I have fax service, and let's configure the fax service to run under a real account instead of local system. And here we should specify the password for that account. And if we will switch back to the secrets and click F5 here, so you will find that there is a new secret here with the name sc underscore sc underscore, which is the indicator that this is the service password here and the name of the service. And we will be able to use Cain to extract the clear text value of the password for that user account. But right now here there is the current value. There is no way you can understand this password here because you need to know the algorithm how to extract the real password from that value, registry value. Okay, so right now let's switch to the Cain because we know the secrets. You know what is machine account, what is the default password, and other items, and we also know that we might find the password for the local service inside of the LSI secrets. Let's try to use Cain and see what will happen. So with the Cain, you need to choose the LSI secrets decoder. Right click on that gray area and click plus here.
Okay, the first option here adds the local system. It's a live system, and it's basically the will show you the information from your real security hive and the LSA secrets from your live machine. When the second option is the offline extraction. And for that one, you need to have two files here, the system hive and the security hive. And both of them, they are by default stored inside of the Windows System 32 config folder. And that's the security hive, and that's this one is the system hive. And with the security hive is really clear. Why do we need to have that? Because basically our LSI secrets, they are stored inside of the security hive. But the system hive that's the question. Why do we need to have the system hive? And the answer is the system key functionality or the boot key, which is the same thing. And let me show you the idea of the system key and the boot key. So this system key or the boot key is the feature which was introduced in Windows 2000, still exists in Windows 10. And the idea of the system key, the first of all, that the system key is the symmetric key for encryption and decryption of some information inside of the Windows system. And it's used to protect the data on rest. So while the system is turned off, when the system is turned off, some of the files and some of the information on the Windows system is encrypted by that key. And the examples of the encrypted data is the SAM file and security file or the registry hives, SAM and security. So if you will open the security hive when the OS is turned off, and basically somehow copy the security hive from one system and it will try to open that file somewhere, all of the information inside of that file will be encrypted and will be encrypted using the system key. And during the system startup process, the system key basically decrypt the protected information. And during the startup, the security hive and the SAM hive, they both will be decrypted by the system key automatically. But the question is still the same, why do we need to have the system hive? And let's run the syskey tool, and that tool will give us the ability to change the settings for system key feature. And if we will click on the update button, you will see that the default option for the system key is to store the startup key locally. And basically, really, that means that the system key will be stored inside of the system hive. So by default, the system key stored inside of the system hive, and during the OS boot up process, startup process, the system will take the sys key from system hive and will decrypt the security hive. So basically, it's very useless protection because the key is stored inside of the system hive, which is not encrypted. Um, there are other options like you can put the system key on the floppy disk, which is not the good idea because it's deprecated. The floppy disk, nobody uses them anymore. And the password, this one you can specify the password, and every time the system starts, you'll need to type that password. To be honest with you, that syskey feature is pretty old feature, and right now it's much better to use the BitLocker for the drive encryption instead of the system key, which also only protects some of the files like security hive. And again, it's not secure by default, it's very um, useless by the default. So, okay, now we know the answer uh, for the offline crack or for the offline extraction to get LSA secrets from the machine, from the different machine. We need to have the security hive with the LSA secrets, and we need to have the system hive with the boot key. Okay, so let's try to get local LSA secrets from our Windows 10 machine. We need to select local system here and click next. And what we'll get nothing, and at the same time, the restart will be scheduled in 1 minute. The reason why we have it here, because of the Windows 10 security features, we have new protection methods for LSA secrets and LSAS process. And the problem that, let's switch to Windows 8.1 here. And the problem is that Cain Enable wasn't updated for Windows 10. Basically doesn't support Windows 10. And it using it uses the method to access LSA secrets, which basically triggered the system to be restarted, and it's like the security violation. I don't know the workaround. I just think that the application itself should be updated. But there are other tools like Mimikatz, and you can use them to extract local LSA secrets from Windows 10, and it has the support for Windows 10. You can do it with no problems. What I have here, I have Windows 8.1, and let's try to do the same action for Windows 8.1. So LSA secrets, next. And you see that everything works, no problems. So basically the Cain can extract LSA secrets from every machine till Windows 10 and probably Windows 2006, 2016. So let's check what we have here. So the first one is our machine account secret. I told you that's the computer account password for AD authentication. And here you can count the number of characters here. 1, 2, 3, 4, and it will be 120 because the computer password by default is the length is 120. The next one, what we have here is the default password, and it's 1Q2W something. So that's the password. And what is default? What is the default password? Now, we have a tool from Microsoft. Basically, that's the sysinternals tool that Microsoft they bought sysinternals like I don't know how many years ago. And you can run the tool, and you can enable the auto logon feature, and you can specify the user and the domain and the password for the user. And basically, every time the system starts, you don't need to put the username and password because it will be automatically authenticated using that information. You can enable it for that user or disable. So in my case, right now, that feature is enabled for the account with the name Mirish, and using basically the password for that account stored inside of the LSA secrets, and the name is the default password. Well, that's our password for our Autologon account. And the next secret is the DP API system. So that's the data protection API key for the system account. And the data protection API is just the set of the um, APIs which were introduced starting from Windows 2000. And using the data protection APIs, you can encrypt your personal data using your personal encryption key. And for example, the credential manager, which we'll be discussing later, it uses the data protection API to protect the information inside of the credential manager. Um, but here, the data protection API system, that's the key. Basically, that's the private key or unique key for our system account. And well, when we will be speaking about the credential manager, you'll learn that every account in the credential manager has its own credential manager set, or like its own credential, like small virtual credential manager. And the same for the local computer account. But The user credential manager set protected by the secret, oh, I'm sorry, protected by the key which is derived from the password, uh, and the system credential manager set protected by system key, data protection API key, which is stored inside of the local security authority LSA secrets. And LKM, you know what it is because that's the basically the key which is used to encrypt local cached credentials. And we'll speak about cached credentials later. Just keep in mind that the key for protection, like encryption of these cached credentials, stored inside of the LSI secrets. Then what we have is you see these RAS dial param something that's this based obviously the seed of the account. So and if you will open the connections here, no, it's not here. You can just open the sharing here, adapter settings. We have here the deal up connection. So basically that's the we have a password saved here and is it here? No, it's okay. So but it's safe for that connection. And that password and the properties of the connection will be saved here in the LSA secrets. And you can see the username here is just basically my account name, Mirish, and that's the password 1Q2WE because that's the same password we have here. So again, inside of the LSA secrets, you can find many interesting things. And the last secret here is the password for the account which is used right now for inside of the fax service. This underscore SC underscore again, that's the um, indicator of the saved credentials for the specific service, and that's the name of the service. And you can find the name, you can find the service here. Let's find this here. Fax here, and that's the name of the service here. And we see that that's the account, and inside of the LSA secrets is the password for that specific account for Mirage. Let's switch to the next. Let's go to the next decoder, and the next one is the wireless passwords. And using the wireless password decoder, you can uh, get a list of the passwords for all saved networks. If you save the password for the network, for the wireless network, you will be able to see that password and the name of the network here in the service SAT identifier. And we can try to do that right now. Just click on the wireless passwords, then right click on that area and click on the plus button. But we're getting some errors here, and you see that VLAN SVC interface subkey something couldn't open, and it looks like a registry key. And the problem here is that if you do not have any wireless adapter installed on the system, you will get that message here. And by the way, I want to show you the good methods how you can detect the activity from the application. You probably know that, but you know, someone for some people it might be interesting. For example, I want to find the real name, real path of the registry key here, and we can use the procmon tool, which is the tool from sysinternals, and right now it's Microsoft tool. I'll show you how to use that. It's pretty easy. So what we want to do, we want to see the here, want to see the registry activity and probably the file system activity. And there is a very nice feature here, this target, and you can say I want to see the activity from that application, from that window. And right now we switch to the We switched. Our target is the Cain application. Let's switch to the Cain, and you can see that there are some operations, actions with the registry right now already in the background. And let's click that plus button here. Run one. Let's do that like a couple of times. You see that there are very many actions here. The new actions. I want to scroll down a little bit here, and you see here name not found something, but that's the path which we saw here. Clicking this one, you see the VLAN SVC interface subkey. That's the same path. So that's HKLM software Microsoft VLAN SVC interfaces. And if there is nothing here, there is no key here, I mean it doesn't exist, that you'll get the error and the kernel will stop the working. I mean stop getting the information for that decoder. Um, so I do not have any wireless adapters in my virtual machine, but I do have some adapters which are connected to my physical computer, physical machine. And let's switch to the Cain, um, which is running on my physical machine, and do the test here. Wireless passwords, plus button, and you will again get some errors here. It's probably because of the some compatibility issues with Windows 10. But at the end, you will get the information you need. So what we have here is the first column is the GUID, the identifier of the adapter, and inside of in the description column, you can find the name of the adapter. In my case, that's the wireless AC something. Here you can see the type of the key for the network connection, for the network. That can be WPA, WPA2, or WEP, web authentication. In my case, that's the WPA2 pre-shared key, PSK, and that's the service SID identifier for the network. That's basically the name of the network. Windows Phone, something, CMC, something. So that's the connection for my Wi-Fi wireless connection for my Windows Phone when I do the internet sharing feature. And that's the actual password for the connection. The next decoder is the Internet Explorer 789 password decoder. And that one is a little bit tricky, and we need to speak a little bit about the Internet Explorer passwords and the type of the passwords you can save using Internet Explorer first, and then we'll come back here to Cain and we'll do some exercises to show how it works, how that decoder works. So, the problem with the credential storage is for Internet Explorer that the different Internet Explorer versions they use different credential storages, and it also depends on the OS of the Windows version sometimes. And let's first start with the type of credentials which you can save uh, using the Internet Explorer. And the first type is the basic authentication passwords. The basic authentication is basically the clear text um, passwords. They are not clear text, they are base64 encoded, but it's not the encryption, it's encoding. And basically encoded text data can be easily decoded without any problem because there is no symmetric key or something involved here. And the basic authentication, the most common place you can find the basic authentication is the authentication portal or sorry, management portal for home um, routers or home access points. And when you log on to that portal, most of the time you will see the basic authentication dialog window when it will be like a password and username here. And there will be a checkbox. It will allow you to save the credentials for that specific um, site for basic authentication. The next type is the auto uh, complete passwords. So the autocomplete passwords, they are so you can save the password for specific forms, for specific sites, and I will show you right after that. Um, so I will show you later the example of the autocomplete, but most of you, I think that you see the like a small pop-up window at the bottom, and the Internet Explorer will ask you, do you want to save the password for that site or not. So the difference here is the first of all, the OS version. For the OS version, the Windows version 8 and newer, till let's say right now it's still Windows 10, all of the basic authentication, here will be auto complete. So all of the basic authentication passwords will be saved inside of the credential manager storage. Okay, and we will speak about the credential manager later in more details at the end of that video. Auto enrollment passwords will be saved in the Windows Vault. That's the new credential storage which was introduced starting from Windows 7, and Credential Manager was introduced first starting from Windows XP. So the next one is the Windows versions which with the version lower than version of the Windows 8, so pre-Windows 8, not including the Windows 8. And for them, it's a little bit different because for them, we have a difference between the Internet Explorer versions. For Internet Explorer version 4, 5, and 6, all of the all of the auto complete passwords and basic passwords, they are safe inside of the protected storage. storage Protected storage. Okay, if the Internet Explorer version is version 7 and all of the newest versions, so 7 till 11, the basic authentication passwords will be stored inside of the credential manager. So there is basically no difference between versions pre Windows 8, let's say pre Windows 8, and the newer versions for basic authentication. But for auto enrollment passwords, with the OS level lower than Windows 8 and the Internet Explorer version 7, 8, 9, 10, and 11, the autocomplete passwords will be safe inside of the Internet Explorer protected storage. So that's the dedicated specific storage for that specific type of passwords for auto enrollment for only specific versions of Internet Explorer for only specific operational systems, so pre-Windows 8 systems. Okay, so let's do some testing here. And the first will be basic authentication passwords. And I have in my lab, I have a small web server with basic authentication enabled. So that's it. This is how it looks like. The window for the dialog window for basic authentication in Windows 10. I need to put the username and password here and check that checkbox and click OK. So I was authenticated as good, and because that's the basic authentication credential, and I hope you remember that all of them doesn't really matter which version of the Windows you're using. I mean, we are speaking about the supported versions. They will be saved inside of the credential manager. And oh, yeah, it was there, but it disappeared for some reasons. Okay, so we have some problems here. Yeah, so because Cain Abel unfortunately wasn't updated for Windows 10, we can get some problems here. So what I will do, I will restart the computer and I will try again, okay? So I did a reboot and basically really I did just a reboot and nothing else. I will try again. So now we can see it. Yeah, sometimes you can get some weird things in Windows 10 because really Cain wasn't updated. It doesn't support the Windows 10 officially. And here we have our username and password, okay? And let's test the autocomplete. I have this URL, this site, which is just a testing of autocomplete feature. So we'll have auto user and the password will be password. Let's submit the form here, and I want to save it here. Yes, save it. And because it that's the Windows 10 and for the version starting from Windows 8 and the newest versions, newer versions, all of the autocomplete passwords will be saved in Windows Vault. And let's check that here. Always we see it here. So the username is auto and the password is password. So in here, basically in Windows 10, you will get, let's try to click the plus button, you will get nothing because that's the specific case. And let's switch to the Windows 10, which is the pre-Windows 8 OS. And remember that decoder is only for autocomplete passwords. And I do have here the autocomplete form, the same form. And let's do the same task here. Submit. Yes, I want to save it. And let's click, because you remember the previous time it was inside of the Windows Vault in the Windows 10, but right now we have nothing here. But here we do have our username, URL, and password here, and the type here, type IE789. But really, what I have here is the Internet Explorer version 10, so it still work because that's really depends on the Windows version, the Windows of the version of the OS. Yeah. So and some limitations for very old Internet Explorer versions like 4, 5, 6, and you remember that they store that information inside of the protected storage. This one. The next decoder is the Windows Mail passwords. And that one is the specific decoder only for Windows Mail and Windows Live Mail applications. So basically, in the Windows XP, uh, the Windows OS has the Outlook Express default mail application. So starting from Windows Vista, it was changed to Windows Mail application, And right now in Windows 10, you can download the, I think it's called Microsoft Essentials. And inside of that Microsoft Essentials package, there is a Windows Live Mail application. So, and they have specific storage for the passwords. And in my case, I installed the Windows Live Mail application, and I have one account here saved, and it's pretty easy to use again. If you have Windows Mail or Windows Live Mail installed locally and you have some profiles with safe passwords, just click on the right area and click plus here. And you can see that there is a one um, profile here, and the username is Mirage and the password is something. And that's the profile from the Windows Mail application. The next decoder is the DLOP passwords. And I hope you remember that when we were speaking about LSA secrets. Let's switch to the Windows 8.1 and get the let's add the LSA secrets here. We saw that we have inside of the LSA secrets we have the parameters for VPN or modem connections here. And it looks like that one is password and looks like this one is the username, but there are also some of the other settings here. So for that purpose, we have a specific decoder which basically takes information from LSA secrets about the VPN connections and RAS connections and parse them and just show the information to you in the more readable representation. And again, if we will try to open the DLL passwords in Windows 10, the Windows 10 will fail. It will not fail because that's for the protection. The Windows 10 will force the reboot, and you will not get any information from LSA secrets. But the Windows 8, let's try this one. Let's go to the dial-up passwords and right-click on that zone and click plus button. And here you can see the same information which we saw in the LSA secrets, but it's for us we have it right now in the more readable view. So that's the DLL connection name, and we have a number inside, the username and password, and the type is the modem authentication. And if you'll open that window, here we have a DLL connection, and there it is. And all the properties of that DLL connections we can see here. So that's the number here, and we see this we see the same number here. Yeah, so that's the all information about the DLL passwords tab decoder. Okay, so the next decoder is the edit boxes. Basically, how it works that you should have some window or application running on the background. Let's open the computer management here. You should open something which has the password input box on the here and user and the new password, okay? Something like that, I don't care. And when that um, dialog box is active, you need to switch to the Cain and click the plus button. And you see here, one of them is the pass something, and the second one is that one. So there is no way you can, see what's the name of the added box or this label, the text from here, but you can see the password you know, which is hidden behind the asterisk here. But the problem with the added boxes decoder, that decoder doesn't work for some of the added boxes. Basically, for example, we have um, mm, which one? Let's try this one. We have the run as different user application here and some password here. Just try this one. And if we will try to use added boxes again, we'll not see anything from that Windows security, this dialog window. The problem is that these uh, password added boxes, they do not store the password on the background. And that's why the Cain is not able to extract that password. So, easily speaking, for some edit boxes it will work, for some of them it will not work. The next decoder is the Enterprise Manager decoder. And for that one I do not have any examples unfortunately, because let's open the help for Cain, this one, the question mark button, and go to the program features and Cain and password decoders and Enterprise Manager. And as you can see here, that's the decoder for Microsoft SQL Server 7 and 2000. Uh, that there is the specific application with the which called my Enterprise Manager for SQL servers. And right now there is no such application anymore for modern modern versions of the SQL, because I think the management application right now called Microsoft SQL Server Management Studio. And if you still have Windows SQL Microsoft SQL 2000 or 7 version 7, and you're using the Enterprise Manager, and if you're using the SQL Server authentication, and you just put the username and password here, that username and password will be automatically saved, unless you check that button, that checkbox here. And Enterprise Manager decoder will be able to get that information, that saved information, from Enterprise Manager. Yeah, I do not have any examples here because I wasn't able to install Windows 2000 Server on the Windows 2008 machine, because simply saying it just doesn't support that new operation system. But you at least know uh, what's the functionality behind that decoder. The next decoder is the credential manager decoder, and that one is a pretty interesting topic. So after the protected storage was decommissioned, and was decommissioned in starting from Windows Vista in 2008 server, the credential manager was introduced as a replacement for protected storage. And the idea of the credential manager, that's the protected storage, and the application developers, they have the ability using the credential manager APIs to put and securely store some information inside of the credential manager. And one of the specifics of the credential manager, that uh, each user, each account has the dedicated encryption key for all of the items inside of the credential manager. And if you will go in deeper, that it might be the dedicated encryption key per application inside of the credential manager. So basically speaking, by default, if I will put something inside of the credential manager as my user account, uh, the different uh, another user account will not be able to read that information, because that account will not know my encryption key. only my user account knows my encryption key. It's basically derived from my password. So to see how it looks like, to see how the credential manager looks like, you need to open the credential manager application. It's here. You can find it in the control panel. And this one, Windows credentials, that's the credential manager itself. So that's the interface, the application to manage. So you can add some specific credentials here. You can add generic credentials. You can add the Windows credentials. And by the way, the good explanation of them you can find inside of the Cain in the help. Cain features Cain, decoders, and credential manager. There it is. And here you can find the difference between the types of the credentials. For example, the generic type, which is that one, you can just simply securely store the credentials, but they will not be used somehow. And if it's domain password credential, then some of the authentication packages, or right now they called SSP, security support providers, they will be able to use them, like Kerberos and Telem or Negotiate. And Negotiate will just negotiate the authentication package between Antelem and Kerberos. So yeah, I'll try to keep it simple. Just a storage where you can put some credentials here, and they will be protected using the uh, encryption key, which is basically binded or connected to your user profile. And what you can see here, you see that one? That's the basic authentication saved credentials from our previous videos. And for example, what you can do, you can add your own credentials here by yourself, I mean manually. You can even add certificate here. What we will do is we'll create an RDP uh, connection. Um, we'll add check that checkbox that will RDP connection RDP client will give us the ability to save credentials. And as you will see, these credentials will be saved inside of the credential manager for our specific user account. We can click connect here, remember my credentials. We'll put my credentials here, connect. I don't, well, that's okay. We do not really need to connect. But because were already connected, the session was started, as you saw, we can switch to the credential manager right now and just let's refresh it. Nothing here. We probably need to refresh it again, or let's try again. Okay, nothing, still nothing here. Probably I just closed the um, just closed the session too quickly. Let's do that again. Okay, yes. Okay, that's my domain controller. That's fine. I'll just disconnect from here. And let's try to refresh it again. Yeah, so I just need to wait a little bit because I closed the connection very quickly and the credentials were not saved. So here we see that that's the Windows credentials here. And by the way, you can open them, you can edit them, but you cannot see what's behind that password. We can even try the edit box. And in the edit box, you don't see anything here. That's strange why that scroll bar is here. Okay. Oh, it doesn't work. Um, and let me show you the real um, path where you can find these um, credentials. We need to open the user profile, and my user is this one, Mirage is the hack lab. And we also need to see the hidden files and the protected operation system files. Um, need to open the user profile, application data, and that's the difference between them. So here, as you can see, you can open the details for that credentials, and you can see that the persistence is the local computer. So basically, that set of credentials will stay on that computer and will not move anywhere. But that one, for example, you see the persistence is enterprise. So it will travel with your profile, basically like a roaming profile, if you will log on to another machine. And the difference in the file system is that the local computer credentials, they stored here in the local Microsoft credentials, these two, and because we have two of them, it's probably that one is local, that one is local, you can see. This one is local. Um, but enterprise credentials, and we have one enterprise here, they are stored inside the roaming Microsoft credentials and that one. So that's the difference. And if, for example, if we will delete one of them, let's delete the local here, this one, virtual app something. You'll see that here in the local we saw two, and right now that's just one of them. Okay, so and um, that was a little bit of theory, but what Cain can show you, the Cain can show you the content, the items inside of the credential manager for the current user. So it's basically the session, our current session, um, our user, you will be able to see all of the items inside of the credential manager which were saved for the current user. That's pretty easy to use. Just click on the right area here and click plus here. I hope it will work because for yeah it will you do not see all of them again because of the errors or something like that. It's very often for the Windows 10 happens with the cane because simply saying doesn't support Windows 10. We can try again, just run it again and open it again. So we have these problems again. I will reboot the machine and we'll try again, okay? Just a second. Okay, so I did after the reboot, let's try again. Credential manager plus button. And hopefully no, still doesn't work still. It's not good. Yeah, so as you can see there are some problems with the compatibility with the Windows 10. Let's try to do that. Try to open the credential manager. Let's delete that one. There's probably some problems with that one, just with compatibility, I don't know. Open that again. Credential managers. Credential manager. Yeah, no, you can see it. So, for the other Windows systems, they will not get these problems. That's mostly because of the compatibility with Windows 10. Um, simply is not compatible with Windows 10. So you can see here is the resource name is term SRV, the terminal connection to the IP address 10.10.10.10.0.10, and that's my username here and the password, the clear text password, and the type is domain password. And here the domain password for inside of the Cain means that that's the Windows credentials. There are some flags, and the SAT is it local or enterprise, and in our case is that's local. And we can see here, we also can see that the last time it was modified, it was something like 7 minutes ago. And that's true. That's the time I just created the connection, um, invoked the connection. And I told you that the credential manager is the has the different encryption keys per user. So, and we can try to, you know what? Let's try to open the credential manager here, that decoder again, just to make sure it works with no errors here, no problems. Okay, it works. And let me change the user. Switch the user to another one, like this one, that guy. Because I told you that uh, the credential manager, for each user there is a dedicated encryption key, and you will not be able to see anything, any stored credentials uh, for one user using the different account. And we'll try it right now. Okay, and just need to open the Cain Abel again. Okay, and credential manager, click plus here, and we see nothing here. Why? Because that's the different account, the different credential manager storage, and we have no ability to see the credentials which were saved for another account. Let's try to open the credential manager again. I don't know what's going on here, but let's open it from here. Where's the command from? Control crap. Panel, credential manager, Windows credentials, and we do not have the credentials which were saved um, for for our um, different account. Okay, so on the last part of the decoders tab, the last decoder is the Windows Vault decoder. And in the previous section, I told you that the credential manager was first introduced in Windows Vista, and that was my mistake because really it was introduced in Windows XP and 2003 Windows Server. And uh, in Windows 7, the Windows Vault, the new credential storage was introduced. And there are some new features in that credential storage, like you can create a backup of the credentials and restore the credentials. You have like the support for new algorithms and also the new features, some other extra functionality. But basically, it's just a new credential storage which you can use to store your personal secrets or passwords or whatever. The Windows Vault has the dedicated vaults for every user account, and at the same time it has a dedicated vault for system account or local computer account. The same the credential manager has the dedicated credential set for computer accounts itself. And if you want to see the objects or the structure of the Windows Vault, you need to, for the current user, for example, to open the users here, open the profile, app data, local, Microsoft, and here Vault, and that one, that's the uh, folder for, that's the GUID for our user account, And inside of that folder, you can see different files. And for example, inside of the policy file, there is an encryption key for all of the secrets in the vault and some of the settings. And that one is the most interesting for us here. That's the saved credentials themselves, vCRD. And by the way, if you want to just get some uh, detailed information or more details about the Windows Vault and the structure, I do recommend you to go there to that site of Passcave, and very good site, and you can see the explanation of Windows Vault and the structure and how it works. I mean, in more details, because I just don't want to go deeper because we are speaking about Cain here, not about the Windows Vault. But the basic information I will tell you. So that's the credentials. And if you'll open the credential manager, you can see here that basically that one is the Windows Credential Manager, and that one is the Windows Vault. And there are some new features like you can see the password itself here, hide and hide, but you can do that only if that secret was saved or was created by yourself, but by your account. Okay? And if we will remove that one, so you will see that this credential is disappear. So that's that object. Okay? Yeah. And let's do the following. Let's open the Internet Explorer and let's just generate some saved credentials again. And that's the autocomplete credentials from Internet Explorer. And basically speaking, here the Internet Explorer. Let's refresh that. Okay, still nothing. Probably I just entered the same password or something. Let's try it again. Click save here. I want to save. Yes, I want to save. Probably just didn't click. Yeah. Okay. And that's the new objects here. The VCRD object was created. Um, if you want to see the objects, the real passwords for your current user account, Vault, you can use Cain Abel here, and simply saying just right click on that area and click plus here. And you'll see that the resource here is our website, the username, the password, and the type, the Internet Explorer in our case. And the type is the same as we have here saved by the application name. Uh, there is also the dedicated storage for the local system account, and it's the location is the following: is system folder, OS folder, config, system profile, app data, local. Here, Microsoft Vault. That's the same. It has the same structure, and you see that there is no saved credentials for the local system account, for computer account. Okay, so yeah, so that's the basic information, the basic stuff about the Cain and all of the decoders. And I think the next video will be about that one, about the tools here, about base64, the VPN, Cisco VPN client, and all of that stuff. Shouldn't be a really long video. I just want to cover that one. So, and then we will start speaking about all of these tabs and how they work. And I hope it will be at least interesting and we'll get more the new information because during mm, during the video I'm just trying to just do not simply show how to click the button and but trying to explain the functionality behind um, every feature of the Cain.